Hi class, today we're going to talk about categorical logic. This is a part of deductive logic. So we often create categories, all ducks swim, all geese are white, whatever the case might be. No firefighters are cowardly. We want to try to identify groups, firefighters, those that are cowardly, those that are mammals, those that are warm-blooded. And then in the midst of doing that, we want to try and make arguments, right? So if all humans are warm-blooded and Socrates is a human, then we know Socrates is warm-blooded, right? By necessity, if the premises are true. So we create categories and then we try to use those to come to conclusions that we think are true. We do this a lot, again, in science or in the law or other places, right? We want to know, how do we define our terms? What do we mean by mammal? If we find something that fits, then we know these other qualities like live birds and warm-blooded and all that stuff would also follow. So categories are very important. It's really easy to make mistakes with categories, so we're going to try to avoid some of that. In the reading, you've already learned about some of how this will work, okay? I don't want you to miss the big picture. We're going to learn about categorical arguments. We're going to learn how to make them well. It's deductive, meaning the conclusions follow by necessity. And if we can do this successfully, it's going to help us pursue the truth in a much better way, right? Again, we're interested in the form of these arguments. The content, the truth of the actual premises is a different question. This is looking at the form of the arguments and whether they're in the logical form or not. So I want to start by looking at Aristotle's square of opposition. So this goes back, 500 years before Christ. Aristotle writes a book titled Logic, where he's unpacking some of these things. And Aristotle would argue, as would I, that logic is not just created by humans, but in fact it's discovered by humans. We discover logic and the truths of logic the way we discover the mathematical force of gravity. We didn't make that up or create it, we discovered it, right? Logical truths seem to hold, and they seem to hold in every possible world, and they seem to hold all of the time, at least when they're deductive. So we have four basic types of categorical statements. Every S is a P, or a lot of times I'll say all S's are P, right? That's an A statement, so you can see that A statement here. So when you hear me say this is an A claim, I'm saying something like all firefighters are brave, right? That's an A claim. The E claim over here is that no S is P, right? There is not one S in existence that is also a P. Here we might say something like no firefighter is cowardly. That would be an E statement. Both of the statements I've made are false in terms of the truth, right? When I say all firefighters are brave, all it would take is one firefighter who's not brave to make that false. I'm so sorry, I forgot to share my screen. Let me go back here, share my screen. All right. Now you're going to be able to see Aristotle's square of opposition. So here's the square here. The A claim, every S is a P. The E claim over here, no S is a P. I've given you examples that would fit the right form. All firefighters are brave fits the form A. No firefighter is cowardly fits the form E. But again, all it would take is one cowardly firefighter, and both of these sentences would be untrue. Again, I could give a true A claim like every mammal is warm-blooded, no mammal is cold-blooded, and we could do it that way. But the key for me is that you know the form that A takes, the form that E takes, okay? The third form is I down here. Some S is P. So there's some existing S in the world that is also a P. Some cats are friendly, right? Some S is P. That's an I claim. The O claim is the fourth and final claim. Some S is not P. Some cats are not friendly. Some cats are not black, right? There's some existing S that is not a P. So these are your four basic categorical forms, and we can do a lot with these. The square shows you the relationships, okay? So how does A and E, how do these two relate? They're called contraries. And what this means is both A and E can be false, but both cannot be true. Okay? Both A and E can be false, but both cannot be true. So if I say every firefighter is brave, no firefighter is brave, right? Every firefighter is brave, no firefighter is brave. Both of those can be false because we might say some firefighters are brave. That would make both A and E false, right? So both can be false. Both cannot be true. If every firefighter is brave, then no firefighter is brave must be false. They both can't be true. If no firefighter is brave is true, then the A claim must be false. So the contrary means both A and E can be false, but both A and E cannot be true at the same time, okay? All right, what's the relationship between I and O? A subcontrary, okay? I and O are subcontraries, and what that means is both I and O can be true at the same time. Both cannot be false. So it's the exact opposite of the relationship above between A and E. Both I and O can be true, but both I and O cannot be false. So again, if I said some firefighters are brave and some firefighters are not brave, both I and O can be true in that situation, right? But if some firefighters are brave, if that is false, then some firefighters are not brave must be true. One of these has got to be true. If O is false, I must be true. If I is false, O must be true. So both can be true, both cannot be false. Okay? So it's a different relationship, but it's similar. That's important. What about A and I? What's the relationship between A and I? A is what we call a sub-implication of I, or I is a sub-implication of A, I should say. If A is true, I must also be true. If every firefighter is brave, then some firefighter is brave, right? So if A is true, I must also be true. I is an implication of A. It doesn't go the other direction. Remember, look at the arrow. It only goes one way, from A to I. It doesn't go from I to A, because saying some firefighters are brave does not imply that all firefighters are brave. Okay? So all firefighters are brave implies some are does not imply that all are. The same thing for E and O. If no firefighter is brave, then we know by necessity that some firefighters are not brave. If E is true, O must also be true, but it only goes one direction. E to O, it does not go from O to E. No firefighters are brave implies that some are not brave. Some are not brave does not imply that none are. Okay? And then finally, what about these diagonal lines, these contradictory, right? A is contradictory to O. O is contradictory to A. It goes both ways. E is contradictory to I is contradictory to E. Okay, what does that mean? It means this. If A is true, O must be false. If O is true, A must be false. It's that simple. That's what a contradictory is. If A is true, O must be false. If all firefighters are brave, if that's true, then some firefighters are not brave must be false. If some firefighters are not brave is true, then all firefighters are brave must be false. Same here. If no firefighters are brave is true, then some firefighters are brave must be false. If some firefighters are brave is true, then no firefighters are brave must be false. Contradictory. So that's sort of the square of opposition. So let's look at these claims a little more closely. A, E, I, and O. And then we're going to start diagramming them. Okay? So here are A sentences. If you see a sentence, you say, this is an A sentence. You say all trespassers are persons who will be prosecuted. All SRP, very clear A statement, right? All SRP is an A. Or you can just say trespassers will be prosecuted, because the implication here is that all trespassers will be prosecuted, right? Anyone who trespasses will be prosecuted. Another way of saying all trespassers will be prosecuted, an A claim. This is key, a conditional. Lots of conditionals are A, right? If anyone trespasses, that person will be prosecuted, right? That's an A claim. If you trespass, you will be prosecuted. All trespassers will be prosecuted. The negative way of saying this, of course, no trespasser will fail to be prosecuted. All trespassers will be prosecuted. So there are different ways of saying it, but when the key is to be able to take the English sentences here and turn them into diagrams that we're going to talk about. Put them into something that's easy to see the way we did with symbolic logic. Okay, E statements, a little bit different. Sorry, excuse me. How do you diagram an A statement? So we're doing A statements, all S or P. This is how the diagram would look for one sentence, right? We've got two categories, S and P. S is trespassers, P, people who will be prosecuted. All trespassers will be prosecuted would look like this. And the reason you shade out this area, right? If S represents everyone who will trespass, if that's what S represents, there are no trespassers over here that will not be prosecuted, right? So nothing can exist in this space, because this space would be people who are trespassers who don't also get prosecuted. So we have to block this out and push every trespasser into this space, the overlap. Every trespasser exists in this space because this is the space where you have a trespasser and someone who's prosecuted, right? P circle, every person who's prosecuted is in the P zone. Every person who's a trespasser is in the S zone. If all trespassers will be prosecuted, we block this section out. We push all the trespassers into this area. Things that are trespassers are also things that will be prosecuted. There can't be anything that exists here that is a trespasser that's not prosecuted, right? Because all trespassers are prosecuted. Now, the reason it doesn't work the other way, the sentence does not say all prosecuted things are trespassers. So all trespassers are prosecuted, that's here. But there are also killers who get prosecuted and rapists who get prosecuted and thieves who get prosecuted. So there are prosecuted things over here that are not trespassers. So you have to leave this open, right? This is the area where all trespassers are things that get prosecuted, so nothing can exist over here. So let's go to E claims, right? E sentences. This is no SRP. No S is a P. No whales are fish, right? Or whales are not fish. Both saying the same thing. Nothing that is a whale is a fish. No whales are fish, right? Nothing but non-fishes are whales. You probably don't want to say that. Here's the key one, the conditional. If anything is a whale, then it is not a fish. No whales are fish, right? So these different English sentences that get diagrammed like an E. So all the A English sentences got diagrammed like an A here. All E English sentences get diagrammed like an E right here. No whales are fish. S, the big category of whales. Every whale is represented inside this category of S. Every fish is represented in this circle called P. If no whales are fish, nothing can exist in this space. Nothing can exist in the overlap because no whales are fish. All whales that exist are here in this area outside the category of fish. All fish that exist are out here outside the category of whale. So you've got to know that every E sentence gets diagrammed like this. As we diagram, we're going to be able to make arguments that really help us determine the truth and falsity of things. All right, I sentences. Some logical principles are things that are difficult, right? Some SRP. Some logical principles are difficult. Some things are both logical and difficult, right? You're saying there's something that is both of these things. Some S are also P. There are logical principles that are also difficult, right? So we're not saying all logical principles are difficult. We're not saying no logical principles are difficult. We're saying some are, which means maybe some aren't, right? This always gets diagrammed. All I statements get diagrammed like this. Logical principles, every logical principle is in the category of S, this circle. This P circle is all things that are difficult. Some logical principles are things that are also difficult. You have to put an X in the overlap. There are some things that are both S and they are P. We put an X because it's at least one. It might be more than one. At least one logical principle is also difficult. Some are, right? Some means one and maybe more than one. The sum is met if just one. If there's just one logical principle that's difficult, then the I statement is true. Some SRP. There might be 100, there might be 1,000, but there has to be at least one. So some are, we put the X there. Okay. Lastly, we have O sentences, right? Some runners are not vegetarians. So some S are not P. Some runners are non-vegetarians. Some non-vegetarians are runners. I love number 4 here. Not all runners are vegetarians. Okay. If not all runners are, then some aren't. Right? By necessity. If not all runners are vegetarians, then some are not. That's still an O statement, right? So we got to take these English claims, translate them. Here's how we would diagram it. Here is the category runner. So S is every runner is in the category S in the circle. P are vegetarians. Every vegetarian exists in the circle P. If some runners are not vegetarians, the X goes over here. There's something that exists here that is an S that is not a P, right? Some means there's at least one runner who's not a vegetarian, and there might be a lot, but at least one, so we get that existential X there, okay? So these 4 claims have lots of different kinds of English sentences. We then learn to diagram them in these ways with categories, the S category, the P category, right? Okay, so I want to show you how this might look, okay? Okay, so the number 1 here, only a mother could love him. So there's an S and there's a P, right? There's a subject and a predicate to the sentence. And we're trying to figure out how to diagram this, right? So again, if it's an A claim, all SRP, it's like this. No SRP like this, right? We black out. There's nothing that exists in the overlap. This pushes every S into the category of P as well. Some SRP, an X between the two. Some S are not P. It's over here. What about this idea that only a mother could love him, right? What we mean are 2 categories. Mothers, subject, predicate, things that love him. If only mothers love him, it means that all things that love him are mothers, right? Only a mother could love him means that anything that loves him must be a mother. All things that love him are mothers. That's an A statement. You block this out. Nothing can love him that is not also a mother, right? So you push the categories of things that love him, right, into the overlap with mothers, because only a mother could love him. The sentence does not say all mothers love him, okay? If the sentence said all mothers love him, then you would block this area out, and you would push the mother category into the category of things that love him. All mothers love him. But that's not what the sentence says. The sentence says only a mother could love him. Only a mother could love him. That means that all things that love him must be a mother, because only mothers could love him, right? It's an A claim. That's what the A is over here. Number 3, right here. The longest mile is the last mile, right? The longest mile is always the last mile. How do we diagram it? Well, we've got the category of longest miles. We've got the category of last miles, right? Those are the 2 things, longest mile, last mile. If the longest mile is always the last mile, then all longest miles are last miles, right? Every time it's the longest mile, it must be the last mile. All longest miles are last miles. So it's an A claim. Nothing can exist over here. Nothing can be the longest mile that is not also the last mile. So we block this out. We push all longest miles into the overlap of the category of last miles as well. So an A claim there. Number 4. Happy is the bride the sun shines on, right? Happy is the bride the sun shines on. What we're saying here is if the sun shines on a bride, she's going to be happy. Sunshine is sufficient for a happy bride. So if the sufficient condition is always the antecedent, that comes first. If the sun shines on you, sufficient condition, then you are happy, right? So the if then, if you remember, creates a nice A claim. Category of happy brides, category of sun shines. If the sun shines on you, you will be a happy bride. So all sunshine brides are happy brides. There can be nothing that exists over here. The sun cannot shine on a bride without her being happy, right? So nothing can exist over here. We've got to block it out, push all brides the sun shines on into the category of all happy brides. Now, that doesn't mean you can't be happy without the sun. There are brides over here that are happy without the sun. It just means that if you're a bride and the sun shines on you, then you've got to be happy by necessity. And so we create that nice A statement. Number 5, no one may be admitted except juniors and seniors. No one may be admitted except juniors or seniors. What you're saying here is only juniors and seniors are allowed in, right? If no one can come in except juniors and seniors, then only juniors and seniors are allowed. So it goes right back to number 1. Only juniors and seniors are allowed in. How does that look? You've got those that are admitted, this whole category of those that are admitted, a whole category of juniors and seniors. If only juniors and seniors are admitted, then all those admitted must be juniors or seniors, right? If you are admitted, you must be a junior or senior. So you got to block this out. You can't be admitted, right, if you're not a junior or senior. So nothing can exist here. We push all those admitted into the category of juniors and seniors. Now, it's not saying all juniors and seniors are admitted. That's not what the sentence says. It says only juniors and seniors are admitted. If it said all juniors and seniors are admitted, we'd have to block this out, right? We'd have to block all this, push all juniors and seniors are those things that are admitted. That's not what it said. It said only juniors and seniors are admitted. So if you are admitted, then you must be a junior or senior. You've got to block this out. Right? Number 6, not all apples are red. Translated, some apples are not red, right? If not all apples are red, then some are not red. So that's what we're saying. Some apples are not red. It diagrams things that are apples, things that are red, right? We got these 2 categories. If some apples are not red, then something exists here in the category of apple that's outside the category of red things. Some apples are not red. That's an O statement. Right? Number 9, valuable lessons are never easily learned. Valuable lessons are never easily learned. So if you're a valuable lesson, you're not easily learned. No valuable lessons are easily learned, right? No valuable lessons are easily learned. So we know this is an E claim, right? No valuable lessons are easily learned. So we got the category of valuable lesson. We've got the category of easily learned. No valuable lessons are easily learned. We cross this out. Nothing can exist here. Nothing can exist in the category that has an overlap between valuable lessons and easily learned. All valuable things are not easily learned. All easily learned things are not valuable. We got an E claim, right? That's how you diagram it. And then finally, number 10, not every good dancer is a good person. Which means some dancers are not good people. Some good dancers are not good people. Not every good dancer is a good person. Some good dancers are not good people. So that's going to be an O claim. Some are not. We have the category of good dancer. We have the category of good person. Some good dancers are not good people. Right? Some dancer exists here, maybe many, that are both good dancers but also not good people. That's an O claim. This is just practice for diagramming A, E, I, and O. And the more we diagram, we're going to get more complicated. We're going to diagram arguments, and it's going to be really helpful. So I hope this is beneficial to you. If you have any questions at all for me, obviously, please let me know. I want to help in any way I can. Good luck, and I'll see you online.